Good afternoon, everyone. Everybody hear me okay? Very good. Okay, I want to start with a story of disruption. I got on the plane on Monday morning from San Francisco to come here to London, and I took Uber to get to the airport. And the taxi driver, he used to be a taxi driver for 18 years. And he tells me that he used to work only 8 days as a taxi driver, 8 days a month, and he was making $4,000, which was a decent living for him. And he says now with Uber, and he's been a taxi driver for 18 years, now with Uber, he has to work 24/7, and he makes less money now than he did when he was a taxi driver before Uber. I mean, it's kind of a sad story, but the reason I wanted to bring up the story of disruption is that if you and your businesses want to be disrupting others and not to be disrupted by others in return, what you do with your applications and what you do in particular with infrastructure that's agile is very, very important. So I just wanted to start a little bit with that story of agility in the data center and how infrastructure is key to that. I personally have been in the infrastructure business for about 30 years. I was at IBM. My last job there, I was CTO for server storage and networking. And after that, I moved to Dell, where I was CTO for server storage and networking. So I've been in infrastructure a long time. And so I'm kind of excited to talk to you about what I think is another evolution in infrastructure innovation and I hope you will agree with me when I'm done here. How many of you have heard of Cloudistics? Just one, two. Okay, very good. So the next year when I come, I want this whole room to have heard of Cloudistics. That's what I want to accomplish. How many of you are working on things like, or are looking into, or have hyperconverged solutions? Maybe Nutanix or SimpliVity. So about 7, 8 people in the room. So what I want to talk to you about is the 4th generation of infrastructure. Hyperconverged is actually the 3rd generation. So I really want to talk to you about innovation that our company, Cloudistics, is working on that we think is going to be the next wave of infrastructure. So a little bit grandiose, but bear with me and see if it bears out. So what I'd like to do is take you through, start from business needs. What do businesses want from infrastructure? What does it take to become like an Uber and disrupt somebody else? What kind of infrastructure would they want? And then we'll talk about the current generation of infrastructures. And then I'll talk about the 4th generation, which is what we're calling Superconverged, and I'll tell you why it's different. In particular, then after that, I will talk about... Better? Okay. I got to keep doing this. Sorry about that. So then I'm going to talk about the company Cloudistics and the product called Ignite, and that is actually a superconverged solution, a 4th generation solution. And so then I'll come back and tell you about how Ignite meets those business needs. So that's the quick summary of what I want to talk about. So in as simple a chart as possible, I just want to take you through 6 simple things that I believe, from what I've heard when I go around and talk to CIOs and IT folks over my career, this is a very simplified view of 6 things that businesses are looking for from infrastructure. Number 1, you want to be able to run a variety of workloads on this infrastructure. You can't just say this infrastructure only works this workload, and for some other workload you need a different kind of infrastructure. So to the extent that you can run as many workloads as possible on the infrastructure, that's a good thing. That's what people tell us. The next 2 points are really about cost. There's CapEx and there's OpEx. And the first, low cost and high efficiency, this is about cost of the hardware acquisition, cost of any software like VMware that you have to have running on the infrastructure, cost of the power or cost of the rack, floor space, etc. And you want high efficiency. You know, you don't want to have cheap storage and then you have to replicate all your data or make 3 copies of your data, and you kind of give back some of what you gained when you did that. The third point is you've got to make it very, very simple to deploy, to use, to manage. This is what lets you disrupt others. This lets you run your infrastructure with very, very few people. I heard earlier today that WhatsApp has only 50 people in their IT, and they're managing a huge business with billions of users. This is the kind of thing that's important from an infrastructure point of view, right? You see some nodding heads. High performance, but not just high performance. You want consistent high performance. You know, you don't want to say, I get good performance, except if some other workload is running at the same time as my workload, then whoops, what happened to the performance of my workload? I want consistency when I run workloads. I want to get the same performance. I want business resiliency. I don't want servers to go down and cause it to take my application out. I don't want storage to go down and take my data out. All of these things are important. And then the last point is, I don't want the infrastructure to be proprietary. It needs to be open so I can keep going forward. It needs to be what I call future ready. There are things coming down the road. There's new kinds of flash devices. There's new kinds of networks. You don't want to be locked into a solution that says, yes, there's a new kind of flash, but I'm sorry, I don't have it in this infrastructure. You want to be able to keep moving forward as the world moves forward, as technology moves forward. So very simple definition of the 6 things that I think are important for businesses. So I want to take you through the first 3 generations of infrastructure, because then I can talk about what is superconverged and why is it different. So the first 3 generations, and I would say if you go out to data centers today, 80% of infrastructure fits the first generation, about 15% fits that second generation, and about 5% fits that third generation. Those of you that said you're looking at hyperconverged, that's about 5% of the infrastructure market today. However, it is the fastest growing. So this is growing at 35%. This is where there's a lot of interest. You know, we are sitting in the Nutanix booth, which is a hyperconverged solution. You know that they went IPO last Friday. Their stock is doing very well. And so that's the third one here. This one, there's 0 growth here. This one's growing about 7% a year. So 0, 7%, 35%, a lot of growth here. And you know, if you look through this, the first one, probably circa 2000, is when people started buying things in silos. You bought the best server you knew from Dell or HP. You bought the best network from a Cisco. You bought the best storage you could from an EMC or a NetApp. And then you took the effort to put it all together. It might take a few months to bring it all together. So time to value was slow. But that's the way we did things until about 2007. That's when the generation of converged infrastructures came along, where people like VCE, I was at IBM at the time, we introduced a solution when I was there called IBM Pure Systems. And there's many others here where you pre-tested the server, the storage, and the network, and you cut out a lot of the time to value at the beginning of the process, because this is all tested and so forth, and you brought them together. And it had other advantages. You could do independent scaling of the server, the storage, and the compute. So depending upon your workload, some workloads need lots of storage, some workloads need more compute, and you had the ability to actually do that. You also got storage redundancy in an efficient way using modern forms of RAID. You didn't have to duplicate or replicate or triplicate your data, and that's all important. I think the main challenges with converged had to do with the proprietariness and the expensiveness of, in particular, the storage capability that's integrated into converged solutions. So Um, if you bought, typically it was attached via a SAN. Managing a SAN was complicated. You had to worry about things like LUN management and multitasking, multipathing, and so storage management is complex, and the storage box itself is complex. The same disk drive plugged into one of these things cost you twice as much as the same disk drive plugged into a whole server, and that's because they were proprietary solutions and they could charge what they wanted. And so that was the fundamental problem with converged solutions. Hyperconverged really attacked that part in red here at the bottom and said, look, the storage is too complicated. It has to be simpler to manage. It has to be simpler in cost. And that's where they completely focused, and I think have done a very, very good job. And in particular, what they did was they got rid of the SAN and integrated the compute and the storage into a single node. And now you could just use direct attached storage on the server and get low cost. They did a very fine job of the management of the SAN, not of the SAN, but management of the storage. Everything was done in an application-centric way. So when you did a snapshot on your storage, you did it on the virtual machine, not on the disk or the LUN. And so there were many things about it that were really very good. So that in many ways, it really attacked what was not so good about converged. And that's what hyperconverged is, really attacking that storage problem and integrating the storage and the server. The thing that is still missing, though, is that they don't really integrate the network. So the network is something that you either already have or you go buy from a Cisco or somebody else. So you got the storage in the server, and that part is good, easy, and simple to use. The part that's missing is the network. And so we think it's really important to get network simple too. It's not just enough to get storage simple, not enough to get server simple. Now, if you go out and you go to your IT and say, I want some resources to run a particular project, it's actually fairly easy to get the compute part right and the storage part right. The reason why that takes 2 weeks to come back to you or 3 weeks to come back to you is mostly around the networking piece, getting that right, making sure that you're doing the right firewall rules around that application and so forth. So we think that getting that networking right is very important, and you'll see that's an important part of what we do in Superconverged. You've got to make that simple too. Not just enough to get 2 of the 3 things simple, you got to get all 3 things simple. That's important. The second thing is you sort of lost some of the advantages of converged when you went over to hyperconverged. In particular, this ability to scale server and storage in an independent way. You lost some of that when you integrated the 2. Now, every time you grow, you kind of grow a little bit of storage and a little bit of compute. Now, the new versions of hyperconverged are doing things to alleviate the problem, but nonetheless, to me, it's still a problem. You're still kind of doing more coupled kind of scaling of the server and the compute. We had actually a user of hyperconverged talk about how over time his server and his storage got completely out of whack as they went with more and more nodes of the hyperconverged solution. He suddenly had a lot of compute relative to how much storage he needed. And this is, by the way, the reason why a lot of the hyperconverged solutions focused on applications like VDI, because VDI fits this model. You grow storage, you grow compute, and that's all good. And so that's why hyperconverged really went after the VDI marketplace. They are now, of course, doing more things. I mean, I'm actually, when I was at Dell, we actually introduced a hyperconverged solution. I was with Dell until a few months ago, so until earlier. So, you know, I'm a fan of hyperconverged, but I'm also pointing out some of the challenges that with the Cloudistics solution we're trying to address. So, coupled scaling and the storage redundancy. A lot of hyperconverged solutions will offer replication or triplication as the way to do it. And in a way, you made storage cheap, and then you kind of gave it back by saying, I'm going to replicate my data in order to get redundancy. So, so those are some of the challenges. So superconverged, so what are we doing? I just want to make it as simple as possible and be available for lots of discussion as needed. But I want to make it as simple as possible. I want to start with hyperconverged. I mean, I think that is a really good place to start. A lot of you are looking at it. Like I said, it's growing at 35% compound growth rate. We know it's good technology. So we're starting and saying, I want to keep the best of hyperconverged. I want to start with hyperconverged, and I want to give you all of the goodness of hyperconverged. Storage is simple, storage is cheap, it's an open solution, it's not proprietary. Very, very good thing. So we're going to keep all that. But I don't want to give up the things that I gave up with hyperconverged. In particular, I want to make sure that I have the decoupled scaling capability. I want to be able to scale server, storage, and networking independently. So that's what we do. And I don't want to insist that you replicate your data. So I want to give you better ways to do redundancy with things like RAID in the way the converged guys did it. So I'm keeping the best of converged and the best of hyperconverged. But that's not enough. I'm going to do 3 more things because my goal is to make it as easy as Amazon or Google infrastructure, but running on-prem. So I want to be the best cloud platform on-premise. And just taking the best of converged and the best of hyperconverged, which is already, I think, very good, is not enough. There's 3 more things we decided we had to do. We had to learn from what is Amazon doing, what is Google doing, what are these guys doing in the cloud. And the first thing is, you've got to attack the network problem. All of them do a form of network virtualization so that you can scale the network as much as you want. And just like virtual machines on CPU, you create virtual networks on top of physical networks. The main thing we did was we did it in a way that you don't lose any performance. So the performance of the virtual network is at line speed. If you've got a 40 gig network, I'll give you a 40 gig virtual network. If you've got a 100 gig physical network, I'll give you a 100 gig virtual network. So try to do it at line speed. This is crucial. But you've got to solve the network problem. You can't leave that alone. It's just too important not to do. The second thing is that we just want to transform the user experience for you. And I think that hyperconverged does a very good job of that. But because it doesn't include the network, you have to manage the network from a separate console than the rest of the hyperconverged infrastructure. And then if you're running VMware, you need something like a vCenter console as well. So you've got to have 3, 4 consoles, and some of you, I'm sure, are actually managing these kind of environments. We want just one console to manage everything, one console to manage the network, one console to manage server, storage, one console for the hardware, one console for the security, just one console to manage everything. So transformational user experience, very important to us. And then the last thing that we added was what we call application centricity. So hyperconverged already does storage management in an application-centric way. You want to do things the way applications want it. We also do networking in an application-centric way. So you can say this application gets its own virtual network. These 3 VMs, which are another application, they get their own virtual network. You can make it as small as you want. You can apply firewall rules against those apps and against those virtual networks. So security is done in an application-centric way. So everything we want to do in an application-centric way. And the last thing we did was we introduced a thing called the application marketplace. So when you go to the screen on the portal, you'll see applications predefined, templates in the marketplace, Splunk or Hadoop or Cloudera or all these other kinds of things. 5 clicks and you can get it up and running. And that's important because at the end of the day, what is infrastructure if not for running applications? So I'll just repeat what I said because this is the one slide, what is superconverged, I just want to make sure you remember what is superconverged. It's really taking the best of hyperconverged and the best of superconverged And then adding three things. Make the network really simple, add network virtualization, make the user experience all in one console, make everything application centric. And that's one chart in a nutshell what we do. So I want to show you two more pictures about what we do. One is a hardware kind of centric picture, next one's a software centric picture. So from a hardware perspective, and you'll see this in our booth, there's three pieces to this. Starting from the bottom, there is the compute block. That compute block right there is a 2U. That 2U has 448 cores. It's the latest Broadwell processors. So there's a lot of compute capacity there. You can support something of the order of 300 virtual machines, roughly speaking, give or take, some number of virtual machines. So there's a lot of capacity there. And then you can scale that independent of the storage, independent of the network. You can just scale that as much as you want. You know, with VMware, many of you are running VMware, there's a limit of 32 nodes in a cluster. And then after that, you got to put another cluster, and then you got to manage separate clusters. We don't have any of that. You can just scale without limit. The storage, again, in a 2U, you can get more than 100 terabytes of usable capacity in a 2U. You know, I was just talking to the chief architect of storage at IBM, and he was saying, how do you do that? You know, ours is only 56 terabytes in a 2U. There's a lot of density packed into that 2U. And it supports 200,000 ops per second with that 2U. So that's a lot of performance. And you can scale that, same as compute, you can scale that, you get linear scaling as you add it. And then the network is also can be scaled, can be auto-scaled as you add more. There's an automatic leaf spine architecture. It auto-deploys, so you make the networking real simple. You add it, it knows, is this a leaf, is this a spine, how does it all work? So all of these pieces are independently scalable, which is really important to what Superconverged is. And all of this is managed by one person. I tried to show one person there managing all of this stuff. You don't have separate for network, separate for hypervisor. It's one person, and it's managed from the cloud. So you don't actually have to have any servers dedicated to running management portals and stuff like that. So this is it from the cloud. It's a SaaS portal, and you can manage all this stuff. You could have Ignite itself be in multiple geolocated data centers, and you can manage all of that from one place. And I re-emphasize the point that you're managing everything, you know, the network, the hypervisor, the storage, the compute, the security, and the apps. All of that is managed in one place. You can see some of the apps that you can run that are in the marketplace. And then just to summarize key benefits, you're able to very easy deployment and provisioning, high performance, 200,000 ops per second, line rate, virtual network virtualization, single pane of glass to manage all this stuff. Everything can be scaled on demand depending on whatever you want to scale, you can scale that. And lastly, very low TCO. We've done some comparisons to public cloud, and we've done some comparisons to hyperconverged. And they're roughly speaking about half the cost of those other things. So very low cost. 5 minutes, okay. So I'll show you in 2 minutes. I'm going to show you some of the software. A lot of the value prop is in the software. And so there's 4 pieces of software. There's the network piece. We've talked a lot about it. Think about it as, if you're familiar with NSX from VMware, think about it as a highly simplified NSX, but it's already comes for free in the box. We can do everything at line speed, which NSX can't do. They do encapsulation. You know, they essentially take a packet and put it inside another envelope and put another address on the outside of the second envelope. We don't do anything like that. We have a very different way of handling things. But effectively, you get it for free in the box. VMware's NSX costs something like $7,000 per socket. So if you've got 8 nodes and a bunch of sockets, it adds up very quickly. We've talked on the top right about the SaaS portal in the cloud application marketplace, single pane, so I'm not going to say more about it. On the bottom left, it's a KVM-based hypervisor that we're using. One of the things that customers really like about it, for example, is the hot plug capability. So if you're running a virtual machine and you decide that you need more memory or more CPU, you can add it on the fly. You don't have to reboot the VM. It just grows and it starts to accept the extra memory that you give it, and it scales as it goes. There are other things about it that are really interesting. One of them is that we do support Docker and containers. So if you're in the microservices style of application development, we have built in the ability to support stateful containers with our storage. And then bottom right, that's our storage, 200,000 ops per second. One of the key things, if you use VMware, you might know that when you go from the virtual machine to the storage, there's actually 3 layers of translation, because you've got the storage provides a LUN, and then VMware puts a thing called virtual machine, a VM file system on top of that. And then on top of that, there are things called VMDKs, which is really a file in VMFS. And then your application is really writing on top of the VMDK. So when you make an I/O call, that's going through the VMDK to the VMFS to the LUN on the storage device. So there's a lot of translation going on. We bypass all of that translation and go direct to storage. And so when we say 200,000 ops per second, you're getting that directly at the virtual machine level. So a lot of people that run apps that need bare metal kind of performance really like what we are providing, because we get rid of those 3 layers of translation. So, and just point out again, we've got everything in the box. You don't have to pay extra for something like an NSX or something extra for VMware. It's all, everything you need is here. There's no extra third-party software to go out and buy to make the infrastructure run. So I'm going to, essentially this chart, I'm not going to walk through it because I've got only 2 minutes left, but everything, those 6 attributes that I told you that I thought was important, and hopefully you agree with me is important, we actually meet all of that, all of those things. We've got workload diversity, we can scale storage compute independently. We've got low cost, high efficiency. I told you how it compares to Amazon and hyperconverged. We got very consistent high performance. I've given you many examples. Our storage, our networking, very high performance. It's really simple to use. You've got to go see the demo in K20. It's amazing. It is transformational, and you really should see it. It's hard to explain. You just have to see it. Business resiliency, and it's open and future ready. It supports Docker and other things. So that's almost my last chart. I went back and talked about Gen 1, Gen 2, Gen 3. Where are they strong? Where are they weak? Hyperconverged, I think, is the best of what's out there, and I give them 50% grades for 3 of the categories, but not 100%. And then we think that the solution we have really does address all of the 6 attributes that we thought was important when we started out. So we really think it is a next generation of infrastructure, a next generation of architecture, which, I think all of you owe it to yourself to at least take a look and see what you think, right? So here's my net of everything. Time out, she tells me. I don't think existing infrastructures are meeting all of the customers' needs. I really think that you do need a new kind of infrastructure. That's what we're calling superconverged. It gives you high performance, low TCO, it's easy to manage, it scales out. We think it's really good for if you want to get Amazon-like experience, but you want to do it on-prem and not go to the public cloud. And the Cloudistics Ignite product is really the first of that generation of product, but I guarantee you it won't be the last. I believe there will be others that will do superconverged. We just happen to be the first. So with that, please do visit our booth, K20. You can sign up and actually see the user interface yourself from your laptop. Just go and test out what we call the virtual lab. So if you just go to that cloudistics.com/virtual lab, you can actually see the user interface. You can actually use it and see what it feels like.